Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is subsequence. So let's go to LeetCode. There you go. All right. So given two strings s and t, return true if s is a subsequence of t, or false otherwise. And they have given us the definition of subsequence that we should already know. If you're doing LeetCode, subsequence, substring, palindrome, anagram, these are basics that we should all be aware of. A subsequence of a string is a new string that is formed from the original string by deleting some. You don't have to delete all of them, so can be none of the characters without disturbing the relative positions of the remaining characters. So this ACE is a subsequence from this string because you have deleted this B and D from in between, but you didn't change the order, so A, C, and E remains right there. So they're saying that this AEC is not a subsequence. Okay, this is a subsequence while this is not a subsequence. Correct. All right. So we just need to check if S is a subsequence of T. So just think about it, like brute force. What would be the brute force way of solving this? You just need to check character by character, characters of S. You just need to check if it exists in this string T from left to right, and whenever you see that first character, then you move to the next character. But when you search that next character, you're gonna start from where you left searching the first character where you found that, because you can't go back. You're not just checking if all the characters exist. You're checking if all the characters exist, and that too in the relative order. Simple. So here, what I'm trying to check is if all the characters of S exist in my T. So I'll say, like, I'll go over the first character. Does A exist? Yes, it does right here. Now does B exist? So I'm going to check in the remaining one for B, okay, for the B. So this is not equal, but this is. So two characters exist. What about C? This is not equals to C. This is not equals to C, but this exists right here. So this S is a subsequence of T. Is a subsequence of T. Let's say if this C wasn't right here, but this C was present in the beginning, then would that be a subsequence? Well, no, because the C had to be in the right order. Okay, you were already done checking till here, but then this C had to exist after you have checked that B. But in this case, in the first example, yes, it is a subsequence. So how do we check it? What would be the best approach? Well, you can just simply have two for loops, or maybe not two for loops, just like one for loop and then one while loop, where you just iterate over all the characters of S, and one by one you maintain an index variable where let's say you're checking this ith character. This is the ith character. You're working on this one right now, and then you will maintain a jth pointer that points to the characters in T. Whenever they are equal, then you move your I to the next one, and then you basically start checking after j plus 1. Okay, so because these are equal, so then you will be checking at j plus 1, which is right here. You will start checking the next character, ith. You can make it way more simple by just iterating over T rather than iterating over S first. So I'll just reverse the order. Let me just get rid of all of this. I'll make it like really simple. Okay, what I'll do is I will switch this order, and I will iterate over T. So I will have an I pointer pointing to the beginning of T, and then I'll have a j pointer pointing to the beginning of S. If Ti equals to Sj, then you will increment j plus equals to 1. Then you will also increment I but else you will increment just I. Okay, you will increment just I. And in this loop that you are running over t, you will also check if this j is actually greater than or equals to the length of s. If that's the case, you return true because you have reached the end. You have checked the last index, which will be basically the length minus 1. But here, if you have already checked, then you will return true. Okay, you will return true. And in the end also, you can just, let's say, you can also basically come out and return true in the end as well. But this is it. This is it. I think this will go very well. And here the time complexity would be big of t. Let's say big of all the numbers in t is m. Here it's n. So time complexity would be m if n is smaller than n. M is greater than n. If they're both equal, then no worries. And for space would be big of 1 because you are not using any. It's an easy problem. I'm just trying, like you must have seen whenever I'm solving like these easy problems, I don't want to go too much into detail. It's your job. It's during those interviews to like actually dive deep into these little edge cases, details, right? That makes you a little more intuitive, introduce more, try to resolve the ambiguity in the problems. So what I'll do, I'll have I pointer and j. I'll just have j in the beginning, and for I in range len t, so I'll say if the character at ith position is equals to the jth position in S, then you will increment j by 1, you will increment I by 1, and otherwise you can even just move this outside if, and since you are incrementing it right here, then you can only check right here if j becomes greater than or equals to the length of s, then you return true. Otherwise in the end you can just return false. Return false. All right, and I think this does the job. So another thing is like the edge cases, ambiguity I was talking about. We can have just if not s, or like let's say the length of s is, if this is equals to 0, then you return true because you don't have to check for the empty string. All right, and you don't want to return false for that empty string, so you want to have this edge case solved right in the beginning. So let's zoom out and test it, and hopefully it should work. Yes, it does. Let's submit. Awesome, 100%. Let's note down the time complexity that we talked about. It's gonna be big of mn, or let's say m, and space complexity, where m is the length of the t, not s. Okay, given if s could not be more than t, otherwise it wouldn't be a substring, right? So this will be 1, the space complexity, because at max you are not occupying any space, you're not storing anything, you're just using this one constant variable. So let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem. Please, if you're watching this video, please start using AlgoYogi, guys. I don't know, I thought I made something really cool, but like I don't really have a lot of people solving the problems here. But anyway, thank you. I would appreciate the support. It's useful. It's a completely free app, and make use of it.